to sleep, perchance to digest. Although Gary's mind is switched off, his digestive system is never off duty. It's still busy working on last night's dinner. Food is the starting point for everything that happens in our bodies. Just digesting this food takes 10% of our daily energy requirements. 70% is expended in keeping the body idling, running the processes that keep us alive. That leaves only 20% of our energy output for all our activities during the day. Food is the fuel that we burn when our muscles work. It provides essential nutrients that keep us healthy. Food also supplies the contents of our internal first aid kit, which repairs damage to the body and gets us back on our feet. Gary's ready for breakfast, the meal that breaks the overnight fast. From table to toilet, the food will make a 24-hour journey through his body. The raw material comes in many shapes, sizes, and tastes. In a lifetime, the average person consumes 8,000 eggs, half a ton of cheese, 6,000 loaves of bread, 1,000 gallons of milk, 24 pigs, and a ton of fruit. Swallowing starts the food machine. As we swallow, a reflex action stops us from breathing. The soft palate is raised to prevent food from backing up into the nose. An elastic flap behind the root of the tongue, called the epiglottis, bends backwards to close off the larynx, the air passage to the lungs. The mouthful is steered safely into the esophagus, a muscular tube with a lining very like skin. Waves of contractions pass along its walls, propelling the contents with such force that you could drink standing on your head. These contractions, called peristalsis, are the start of an ever-rolling conveyor belt that carries food and drink through the entire process of digestion. Just the thought of food is enough to make your mouth water. 3 pairs of salivary glands produce 2 pints of saliva every day. It pours through miniature fountains from under the tongue to lubricate the food and make it easier to swallow. It also keeps the mouth and tongue moist. Saliva really starts gushing when there's food in the mouth, or even when you think of something tasty. From here, the food has a twisting 36-foot journey through the digestive system. It will be subjected to physical and chemical attack as the body systematically dismantles the complex ingredients of food into the basic nutrients it can utilize. Chewing starts the assault. The mouth is loaded with 32 teeth designed to mill, cut, and tear. The white surface of the teeth, enamel, is the hardest substance in the body, as hard as glass. Yet it's a living tissue and can repair minor damage to its surface. As the teeth demolish the physical structure of solid food, saliva mounts a second attack. It contains 2 enzymes, chemicals that help pull apart the food's complex chemical structure. One of these enzymes breaks down starch molecules into sugar. To test this, chew something starchy for a minute or 2 and you can taste the result of this chemical reaction, a sugary sweetness in your mouth. The mouthful of food, or bolus, is squeezed down the esophagus, a journey of only 3 seconds. This is the gateway to the stomach, a valve at the bottom of the esophagus. Beyond is the inside of a muscular bag, about the size and shape of a boxing glove. The stomach is a food processor. It pulverizes what we eat, diluting or concentrating it, preparing it for the next stages of digestion. It's also a reservoir for holding food between meals. This cavern is the stomach at full stretch, at its maximum capacity of 3 pints. Strong acid pours in, attacking and breaking down food. Mysteriously, it remains safe from its own corrosive contents. The secret lies in its convoluted walls. They are covered with deep pits, each lined with microscopic cells. In a bizarre balance, some of the cells release hydrochloric acid, while their neighbors secrete a sticky mucus. This coats the stomach walls and protects it from self-destruction. The stomach lining pours out almost a gallon of gastric juice a day. Like saliva, these glands can start to water at even the thought of food. The corrosive gastric juice also contains an enzyme called pepsin. It dismantles proteins into their basic molecules, amino acids. Little absorption of nutrients happens here, but food stays for 2 to 6 hours. Waves of muscular contractions in the stomach churn, squeeze, and blend the food into a thick paste called chyme. This helps the digestive juices to get to work. Our versatile food machine can't cope with everything we throw into it. Some foods have structures that we simply can't digest unless we give nature a helping hand. Our digestive system can only absorb the nutrients from potatoes and soybeans after we've changed their chemical structure by cooking. Fire has been the cook's ally since prehistoric times. Heat loosens the fibers holding proteins and carbohydrates together. Cooking also destroys many of the harmful bacteria which find homes on our food. Appetizing aromas and flavors also play an important role. They stimulate our glands to produce saliva and gastric juice. They also bring a special pleasure to cooking. Well, some do. This slice of bread burns up in just a few seconds. If it released its energy as quickly in the body, we'd also go up in a puff of smoke. The body has more subtle ways of extracting energy from food. But no matter how the energy is released, the same foods will always release the same amount of energy. This experiment reveals the amount of energy in ordinary white sugar, exactly ½ a gram of pure carbohydrate. Energy is measured in calories. In the bomb calorimeter, the sugar burns in a flash. It produces 2 calories. A teaspoonful of sugar will give 20 calories. All carbohydrates produce about the same amount of energy. Other foods may be more or less efficient energy stores. Fat contains over twice as many calories as carbohydrate. While the sugar in our diet gives us instant energy, fatty foods provide us with a more concentrated form of fuel. It's almost 3 hours since Gary had breakfast. Most of it has now left his stomach and is starting its 20-foot journey through the small intestine. If our digestive tract were a straight tube like a worm, we would have to be 30 feet tall. Instead, our intestines are neatly looped into coils to fit inside a convenient-sized body. Peristalsis continues its conveyor belt roll, moving the chyme out of the stomach through this tiny non-return valve. Each contraction forces less than a teaspoonful of chyme on into the top of the small intestine, the duodenum. Here, the inner surface of the gut changes to a moist, velvety lining. It's specially designed to absorb the broken down constituents of food. These tiny finger-like projections, called villi, increase the area for absorbing nutrients. They give the lining of the small intestine an area 10 times greater than the surface of your skin, enough to carpet a living room. This is where nutrients pass from the intestine into the bloodstream. Each of the tiny villi contains a network of blood vessels which absorb glucose and amino acids, the building blocks of carbohydrates and proteins. Fat flows into tiny tubes in the villi. These connect to another of the body's plumbing systems, the lymphatic vessels, which eventually empty into the blood circulation. This dense network of microscopic tubes is wrapped around the small intestine to carry away the components of food. After we've eaten a heavy meal, blood floods to these capillaries from other parts of the body, leaving our muscles weak and our brains foggy. We are what we eat, and a healthy body needs a balanced diet. The science of nutrition has pinned down the essential ingredients. From thousands of different foods, our bodies need only 40 different nutrients. There's no such thing as a perfect diet. What is meat to some is poison to others. But somehow we have to take in the essential nutrients we need to stay alive. Fruits are rich in sugars, minerals, and vitamins. This is a crystal of pure vitamin C, found in citrus fruits like oranges. It's responsible for the health of our bones, gums, and teeth. Vegetables are an excellent source of carbohydrate. They also supply vitamins and minerals, keeping us bright-eyed. Fish provides vitamin E. Meat and dairy products contain protein, fats, and calcium for healthy nails, skin, and hair. Beans are an excellent source of nutrients, but many raw beans are toxic until they've sprouted. Cereals contain indigestible material called roughage. Its bulk helps to keep food moving through the intestine. In contrast, we need only tiny amounts of some vitamins, just a teaspoonful in a lifetime. To digest all these different substances, 3 organs packed around the stomach produce a cocktail of digestive juices. The liver, the gallbladder, and the pancreas discharge their chemicals into a single duct, which runs along inside the duodenum before emptying through a tiny valve called the sphincter of Oddi. Every day, the liver produces 2 pints of green liquid called bile. As chyme flows into the intestine, bile helps to break up globules of fat and some vitamins so they can be absorbed. Waves of peristalsis propel this chyme, loaded with acid, deeper into the small intestine, endangering its delicate lining. So nerves in the intestine walls trigger the pancreas to manufacture an alkaline liquid which neutralizes the acid. This pancreatic juice also contains powerful enzymes. They finish the process of breaking down the ingredients of chyme into simpler molecules. This is where the body begins to reassemble those building blocks. The liver is the largest organ in the body, with over 500 different functions. It's a busy chemical factory made of 75,000 identical groups of cells. It filters out nutrients carried by blood vessels directly from the small intestine. Here, they are recombined into the highly complex protein and fat molecules that the body requires. It's also a store of sugar, which provides energy on demand. The body's energy supply is controlled by the liver. We've already seen it's easy to measure the amount of energy foods like sugar can release quickly and violently. This laboratory experiment measures how the human body releases energy more slowly. It doesn't detect energy directly. It analyzes the air that Sarah breathes. As her body burns sugar, it uses up oxygen. By measuring the difference in the amount of oxygen between the inhaled and exhaled breath, the computer can calculate her production of energy. The flat line on the graph shows her body is just idling. She's at rest.
Okay, Sarah, let's start doing the exercises now.
When Sarah starts exercising, immediately her oxygen consumption rises. Her muscles need fuel, so the liver kicks in with extra supplies from its energy stores, provided by earlier digestion. Six hours after breakfast, the food, stripped of its nutrients, starts the final stage of its journey, a slow trek of 5 feet through the large intestine. This is the setting for the third stage of digestion. Huge numbers of bacteria reside in the large intestine, living on the remains of our digested food. These bacteria are quite harmless in the digestive tract. In fact, they help us out by making small amounts of some vitamins. Bacteria, not the remains of food, make up most of our solid waste. The last component is water, a substance so important that the body is constantly reclaiming it from our waste products. Water makes up 60% of the human body, 10 gallons in all. Even so, we are in constant danger of drying out. To play its part in our water control, the lining of the digestive tract changes as we enter the large intestine from cells that absorb nutrients to cells designed to filter out water. Our digestive juices have turned the original food into a slush, and the body needs that water back. 2/3 of the water in chyme is extracted by the large intestine, filtered out by a microscopic sieve of cells. Thousands of blood vessels in the intestine wall soak up 10 pints of water every day. A dense network of capillaries carries the reclaimed water and absorbed nutrients away from the intestines and back into circulation. The muscular walls of the large intestine force its contents onward to the rectum, the end of the 30-foot journey through the digestive tract. Water drained from the large intestine may end up in the skin. Sweat glands secrete water to cool us when exercising hard or on a hot day. We can easily sweat a couple of pints without even noticing. As we breathe out, an additional pint of water is lost in the warm, moist breath. Even without strenuous exercise, we need to replace as much as 5 pints of water every day. The organs in charge of our water balance are the 2 kidneys. They filter the blood, excreting any waste, through long tubes, shown here in red. Wide arteries and veins ensure a plentiful flow of blood through the kidneys. All of the blood in the body passes through them every 5 minutes. That's 400 gallons a day, 10 million gallons in a lifetime. Each kidney contains over 1 million filter units. Blood flows through a knot of capillaries. Water and waste is filtered out, then collected by intertwined tubes. 99% of the cleaned water is then returned to the blood. The remaining liquid, urine, flows into collecting ducts and then down long tubes called ureters. Just a few pints of urine flow through these tubes every day. The amount depends on how much we drink and how much we sweat. Urine is produced slowly during sleep and quicker during activity. The 12-inch journey ends in the bladder. Urine pulses from the end of the ureters. Its muscular, elastic walls expand as it fills. When empty, the bladder is the size of a walnut. It can grow to the size of a fist before it needs to be emptied. The food machine runs mainly on automatic, but the final stage, excretion, is under our conscious control, just like the first part of the digestive process. Eating, digesting, and excreting is an endless cycle. Even the most exotic foods have but one purpose: to keep us alive and healthy. Thanks to the unseen work, day and night, of our uncomplaining food machine.